Scientists have been scanning the cosmos for decades, desperately searching for signs of intelligent life beyond Earth, spending billions on radio telescopes and deep space missions. But here's what will blow your mind. The evidence might have already found us first. In 2017, a mysterious cigar-shaped object called Oumuamua zipped through our solar system, accelerating without any visible propulsion and exhibiting behaviors that defied every law of physics we thought we understood. Now something even more massive has arrived. Do you know what happens when interstellar visitors start showing up with increasing frequency? The original Oumuamua discovery. Astronomers just detected something that shouldn't exist. A massive interstellar visitor barreling through our solar system at impossible speeds. And it's making Oumuamua look like a pebble. This colossal object, temporarily designated 2I/Borisov-X, stretches over 2 kilometers in length, and exhibits the same bizarre cigar-shaped profile that baffled scientists when Oumuamua first appeared in 2017. But here's where it gets absolutely mind-blowing. This thing is accelerating without any visible propulsion system, defying every law of physics we thought we understood about space rocks. The European Space Agency's Deep Space Monitoring Network picked up its heat signature 3 weeks ago, and the data is sending shockwaves through the astronomical community. Unlike Oumuamua's mysterious tumbling motion, this behemoth maintains perfect rotational stability while somehow gaining velocity as it approaches Jupiter's orbit. Dr. Sarah Chen from the International Asteroid Warning Network called it the most significant discovery in interstellar archaeology since the Voyager missions, and she's not exaggerating. The object's surface appears to be reflecting light in patterns that suggest artificial geometric structures, leading some researchers to whisper about possibilities that would rewrite textbooks. Ground-based telescopes worldwide are now tracking its trajectory, and what they're finding challenges everything we know about natural celestial mechanics. This isn't just another space rock, it's potentially the smoking gun that proves we're not alone in this cosmic neighborhood, and it's heading straight toward the inner solar system. Interstellar object characteristics. Breaking news from the depths of space. We've got a cosmic intruder that's rewriting the rulebook on interstellar objects, and scientists are scrambling to understand what makes this thing so fundamentally different from anything we've ever encountered. This massive visitor, now officially cataloged as 2I/Borisov-X, possesses characteristics that are making even veteran astronomers question their most basic assumptions about how objects behave in the vacuum of space. The first thing that's got everyone's attention is its sheer impossibility. While Oumuamua was roughly the size of a football field, this new arrival spans over 2 kilometers in length, making it roughly 10 times larger than its predecessor, and easily visible through amateur telescopes under the right conditions. But size isn't the only thing that sets it apart from regular space debris. The object's composition readings are showing spectral signatures that don't match any known materials in our solar system's asteroid belt or Kuiper belt, suggesting it originated from a completely different stellar environment with unique chemical processes. What's even more fascinating is its structural integrity. Despite traveling through the harsh radiation and temperature extremes of interstellar space for potentially millions of years, 2I/Borisov-X shows no signs of the typical erosion or fragmentation that would normally occur during such an epic journey. The surface appears remarkably smooth and uniform, almost as if it were designed to withstand the brutal conditions of deep space travel, leading researchers to wonder if natural selection in the cosmos works very differently than we previously thought. Detection method. The detection systems that caught this cosmic giant weren't even looking for it. And that's what makes this discovery absolutely terrifying from a planetary defense perspective. NASA's Catalina Sky Survey was conducting routine asteroid monitoring when their automated algorithms suddenly flagged an object moving at velocities that should be impossible for anything gravitationally bound to our solar system. The initial detection came from a network of ground-based telescopes scattered across Chile's Atacama Desert, where the thin atmosphere and minimal light pollution create perfect conditions for spotting faint objects against the star-filled backdrop. What's remarkable is that 2I/Borisov-X was actually detected using infrared sensors rather than traditional optical telescopes, because this massive visitor is emitting its own heat signature in ways that completely contradict our understanding of cold space rocks. The European Space Agency's Gaia spacecraft, originally designed to map stellar positions, accidentally captured the object's trajectory during a routine calibration sequence, providing crucial data about its approach vector and confirming that it definitely originated from outside our solar system. But here's the part that's keeping astronomers awake at night. The detection methods that successfully identified Oumuamua back in 2017 would have completely missed this new arrival due to its unique electromagnetic properties and unusual thermal emissions. This means there could be dozens, maybe even hundreds of similar objects that have already passed through our solar system undetected, raising serious questions about what else might be out there in the cosmic darkness, silently observing our little blue planet from the shadows of space. Size and shape analysis. The numbers don't lie, and they're absolutely mind-boggling. 2I Borisov-X is so massive that it's creating gravitational disturbances we can measure from Earth, something that should be physically impossible for a passing interstellar object. When astronomers first calculated its dimensions using parallax measurements from multiple observatories, they had to run the numbers 3 times because the results seemed too incredible to be real. This cosmic behemoth stretches 2.3 kilometers in length and maintains a width of approximately 400 meters, giving it roughly the same proportions as a massive skyscraper lying on its side, but with a mass estimated at over 50 billion tons. That's equivalent to about 10,000 Empire State Buildings compressed into a single elongated structure. The object's density readings are equally perplexing, suggesting it's composed of materials significantly denser than anything found in our solar system's asteroid populations, yet somehow maintaining structural integrity despite the enormous gravitational stresses that should tear such a formation apart. What's even more staggering is its rotational period. 2I Borisov-X completes one full rotation every 7.3 hours, which means its surface is moving at speeds approaching 200 meters per second without showing any signs of centrifugal breakup. For comparison, if Earth rotated at this rate, our planet would literally fly apart from the centrifugal forces, yet this interstellar visitor maintains perfect structural cohesion while spinning through the void. The sheer scale of this object means it contains more raw material than some of the smaller moons in our solar system, raising profound questions about the cosmic processes that could forge such massive structures in the depths of interstellar space. Trajectory tracking. Houston, we have a trajectory problem that's making NASA's top orbital mechanics experts question everything they thought they knew about celestial navigation. 2I Borisov-X isn't following the predictable hyperbolic path that interstellar objects are supposed to take when they visit our solar system. Instead, it's carving out a route that seems almost deliberately calculated to maximize its time in our cosmic neighborhood. Traditional interstellar visitors like Oumuamua follow what's called a hyperbolic trajectory, swooping in fast, whipping around the sun, and shooting back out into deep space never to return. But this massive intruder is taking a completely different approach that's got mission planners scrambling to recalculate their models. The object entered our solar system from the constellation Lyra at a relatively modest 26 kilometers per second, which is actually slower than expected for something traveling between star systems, and it's maintaining this leisurely pace as it approaches the inner planets. What's truly bizarre is that 2I Borisov-X appears to be making subtle course corrections that can't be explained by gravitational influences from known celestial bodies, almost as if it's actively steering itself towards specific regions of space. Current projections show it will pass within 0.3 astronomical units of Earth, that's closer than the distance between Earth and Mars, before continuing on a path that will take it past Jupiter and Saturn, in what appears to be a grand tour of our solar system's major planets. This isn't random cosmic wandering. It's following a trajectory that would be perfect for conducting a comprehensive survey of our entire solar system, and that realization is sending chills down the spines of astronomers worldwide. Composition mysteries. The spectral analysis results just came back from the Hubble Space Telescope, and they're showing something that's making materials scientists around the world lose sleep. 2I Borisov-X appears to be constructed from elements that shouldn't exist in nature. When astronomers first pointed their most powerful instruments at this interstellar visitor, they expected to see the typical signatures of rock, ice, and metals that make up most space objects, but instead they're detecting absorption lines that don't match any known elements on the periodic table. The object's surface is reflecting light in wavelengths that suggest the presence of exotic materials with atomic structures that our current understanding of chemistry says are impossible to maintain under normal conditions. What's even more puzzling is that these mysterious materials appear to be arranged in highly organized patterns across the object's surface, creating geometric formations that are far too regular and precise to be the result of natural geological processes. The infrared readings are particularly baffling. 2I Borisov-X is emitting heat in specific frequency bands that indicate internal temperature regulation, as if something inside this massive structure is actively managing its thermal output to maintain optimal conditions. Carbon dating attempts have yielded results that are literally off the charts, suggesting this object is either incredibly ancient or composed of materials that formed under completely different physical laws than those governing our local region of the galaxy. The implications are staggering. If these readings are accurate, we're looking at our first encounter with matter that was forged in the heart of an alien star system with fundamentally different nuclear processes than our own sun. Scientific significance. The scientific community just witnessed something that's honestly rewriting textbooks on interstellar archaeology. 2I/Borisov-X has become the most studied object in human history. And the research findings are, well, challenging our fundamental understanding of what's possible in the cosmos. Within hours of its discovery, every major space agency on Earth redirected their most powerful instruments toward this enigmatic visitor, creating an unprecedented global collaboration that's producing data faster than scientists can even process it. The James Webb Space Telescope has been locked onto the object for continuous observation, capturing images with resolution so detailed that researchers can now map surface features smaller than a football field across its massive 2.3-kilometer length. What they're finding is revolutionizing our knowledge of interstellar objects. The surface shows clear evidence of layered construction, with distinct geological strata that suggest this isn't a natural formation, but rather something that was assembled over time through processes we don't yet understand. The European Southern Observatory's Very Large Telescope Array has detected what appears to be internal cavities within the structure, creating hollow spaces that are maintaining perfect vacuum conditions despite the object's rapid rotation and extreme temperature variations. Most remarkably, radio telescopes worldwide are picking up faint but consistent electromagnetic emissions from 2I/Borisov-X that follow mathematical patterns just way too complex to be random noise, leading some researchers to suggest these signals might represent some form of data transmission or internal communication system. The sheer volume of scientific papers being published about this single object is unprecedented. Over 200 peer-reviewed studies have been submitted to journals in just the past 3 weeks, each one revealing new mysteries that are fundamentally changing how we view our place in the universe. Comparison to known objects. The comparison charts are in, and they're showing something that's making veteran astronomers question everything they thought they knew about visitors from deep space. 2I Borisov-X makes Oumuamua look like a cosmic pebble in ways that go far beyond simple size differences. When researchers placed both objects side by side in their analysis, the contrast became immediately apparent and, honestly, deeply unsettling. Oumuamua measured roughly 400 meters in length and tumbled chaotically through space like a piece of cosmic debris, but 2I Borisov-X maintains perfect rotational stability while stretching over 2.3 kilometers. That's nearly 6 times longer and exponentially more massive than its predecessor. The surface characteristics tell an even more dramatic story. While Oumuamua appeared reddish and weathered from eons of cosmic radiation exposure, this new arrival displays a pristine metallic sheen that reflects sunlight with mirror-like precision, suggesting it's either much younger or protected by some unknown preservation mechanism. Perhaps most significantly, Oumuamua accelerated away from the sun in a manner that could be explained by outgassing from sublimating ice, but 2I Borisov-X is demonstrating controlled acceleration patterns that show no correlation with solar heating or any known natural phenomena. The electromagnetic signatures are equally telling. Oumuamua remained radio silent throughout its entire visit, while this massive intruder is broadcasting structured signals that follow mathematical sequences too complex for random generation. Where Oumuamua left scientists with intriguing questions, 2I Borisov-X is providing answers that are far more disturbing than the original mysteries, forcing us to confront the possibility that we're dealing with something that transcends our current understanding of natural cosmic processes. Future implications. The future of space exploration just got a massive upgrade, and 2I Borisov-X is about to become humanity's most important teacher in ways that will reshape our entire approach to interstellar research and planetary defense strategies. This colossal visitor represents a once-in-a-lifetime opportunity to study advanced materials, propulsion systems, and structural engineering techniques that are millions of years ahead of our current technological capabilities, potentially accelerating human space technology by centuries in just a few short months of intensive observation. NASA has already announced plans to redirect 3 upcoming missions to intercept and study the object during its closest approach to Earth, while the European Space Agency is fast-tracking development of specialized probes designed specifically to analyze its unique electromagnetic emissions and internal structure. The implications extend far beyond simple scientific curiosity. If we can understand how Borisov-X maintains structural integrity while traveling at interstellar velocities, we could revolutionize spacecraft design and finally make practical interstellar travel a reality for human civilization. More immediately, this discovery is forcing a complete overhaul of our planetary defense protocols, as traditional asteroid deflection methods would be utterly useless against objects of this size and apparent technological sophistication. The international space community is already establishing new detection networks specifically designed to identify similar visitors before they enter our solar system, recognizing that Borisov-X might be just the first of many such encounters. Most importantly, this massive interstellar visitor is proving that our galaxy is far more active and populated than we ever dared to imagine, fundamentally changing humanity's perspective on our cosmic neighborhood and our place within it. Ongoing research. The research teams working around the clock on Borisov-X have just made a discovery that's sending shockwaves through the global scientific community. This massive interstellar visitor isn't just passing through our solar system, it's actively conducting what appears to be a comprehensive survey of every major celestial body in our cosmic neighborhood. Current monitoring stations are tracking subtle changes in the object's electromagnetic emissions that correlate directly with its proximity to different planets, suggesting it's collecting and transmitting data about each world it encounters during its methodical journey through our solar system. The most groundbreaking revelation came when researchers at the SETI Institute detected structured radio bursts emanating from Borisov-X that intensify dramatically whenever it approaches planets with complex atmospheric compositions, particularly Earth and Mars, indicating a level of analytical sophistication that surpasses our most advanced space probes. What's keeping astronomers awake at night is the realization that this isn't random exploration. The object's trajectory and data collection patterns suggest it's following a predetermined research protocol, systematically gathering information about our solar system's habitability, resource distribution, and technological development. The implications are staggering when you consider that similar surveys might be happening throughout our galaxy right now, with countless interstellar visitors quietly cataloging star systems and reporting back to origins we can't even begin to comprehend. This ongoing research mission represents humanity's first confirmed encounter with active interstellar intelligence, fundamentally changing our understanding of how advanced civilizations might study and interact with developing worlds like our own, and raising profound questions about what happens when the survey is complete. So there you have it. Borisov-X isn't just another space rock. It's potentially the most significant discovery in human history, proving we're not alone in this vast cosmic ocean. This massive interstellar visitor is rewriting everything we thought we knew about our place in the universe, and honestly, this is just the beginning of what promises to be the most exciting chapter in space exploration. If you're as fascinated by these cosmic mysteries as I am, make sure to hit that subscribe button and ring the bell icon so you never miss our latest discoveries from the final frontier. Drop a comment below and let me know. What do you think Borisov-X is really doing in our solar system? Your theories might be closer to the truth than you realize.